All right, so make sure you watch the previous parts of the lecture so that you understand the meaning of this matrix. It's the example we discussed there. So we have, as I said, in total 4 possible non-absorbing states for a typical student in college, right? The level being freshman, sophomore, junior, and senior, and the absorbing states being dropped or graduated from college. And remember, these are first in the matrix, the absorbing states. So that is the order of the rows and columns. So for example, if you want to look at transition from sophomore to junior, you're going to look at the 4th column and 5th row. So 1, 2, 3, did I say that right? No, the 4th column, 1, 2, 3, 4, and the 5th row, which is over here. So that's 0.7. And then of course from sophomore to be dropped will be 0.3, right? Because again, the dropped the dropped state is in the 1st column. So if you split the matrix into 4 pieces, as I showed you before, to isolate the identity matrix in this corner, then the S matrix, and again pay attention because that's important to the rows and columns, the S matrix will be with 4 rows and 2 columns. Because each row is a non-absorbing state, freshman, sophomore, junior, senior, and each column is an absorbing state, dropped, graduated. So I'm pointing this out because in some cases the number of absorbing and non-absorbing states are equal, and this matrix in that case will be a square matrix, but you might be under the wrong impression that S will be always a square matrix, which is not the case. Remember, rows will be non-absorbing states, columns will be absorbing states. The Q matrix is a square matrix always, given by the number of non-absorbing states, which is 4 by 4. So that's the Q matrix, extract from the right down column corner. And you're going to need the identity matrix with the same number of rows and columns, which is I4, and in this case I denoted by I4. So let's just enter this in Maple to compute it. And then now we're going to perform the inverse of I4 minus Q. So we're going to subtract Q from I4 and find the inverse, and let Maple do that for us. That's the inverse matrix. And remember, the meaning of this fundamental matrix is to give you an estimate of number of trials until absorption if you start in a non-absorbing state. So let's say we start with the freshman state, which is, in this case, is row 1. Row 1, which is basically row 3 from the original matrix, right? But in this fundamental matrix, each row represents a non-absorbing state. So if you start in freshman state, the sum of the entries of this row, so we're going to copy them here in the math mode, the sum of them gives you an estimation, expected number of trials until absorption. And again, absorption in our context means either graduate or dropped. So again, we kind of expect this number, right? Because there are 4 years in college. Each year there is a chance to actually drop. So, and then in the last year there's a chance to drop or graduate. So on average, it takes 2.35 trials to reach one of these states, graduate or dropped. Furthermore, if we want a more precise outcome in the long run, we multiply T by S, and that will be a matrix which is not always a square matrix, right? Because again, in this matrix, in T times S, the rows will be the non-absorbing states, the columns will be the absorbing states. Each entry is a probability, which will give you the probability of eventually coming into that absorbing state. So for instance, if I ask the probability that a freshman eventually drops, the freshman is on row 1, drop is column 1. So precisely this number here is going to be the probability of being absorbed in the dropped stage, right? So the probability that a freshman eventually drops. And then of course, the complement 0.3024 is that the freshman eventually graduates. And you notice that the probability decreases as you move along in the process because, as you get closer to being the senior in the college, then there will be obviously fewer chances to drop. What is the probability that the junior eventually graduates? Well, the junior is on the 3rd row, graduate column is on the 2nd column. So That's gonna be the probability that why doesn't it appear with red? The probability that the 0.72. I'm doing something weird with Maple, I guess. Let's see. 0.72. All right. My next example. Something is weird with what I wrote here. Anyway. So I hope it's clear in terms of the meaning of T times S, right? For instance, let's talk about another one. I'm not going to write it down. What's 0.28? What's the meaning of that? Well, the probability that a junior, right, eventually drops 0.28. All right, so my next example is the gambler's ruin problem, but a little bit more complicated than the one I wrote in the notes. Let's say you have more possibilities. Let's say you start with $4. Excuse me, not start. Let's say you stop at $4 if you accumulate $4, or obviously if you go broke. So with each trial, you either win $1 or you lose $1. So that means the possible states are 0, 4, 1, 2, 3, because you stop at 0 or at 4, and at each point you either gain $1 or lose $1. So for example, if I start with $2, I can lose $1 and I get 1. Or get $3. If I have $3, I can get $4 and then I stop and take my winnings, or I go back to $2 and so on. So take a moment maybe to write the transition matrix yourself, and again pay attention the way you arrange the states here. You start with 0, 4, the absorbing states, and then 1, 2, 3, the non-absorbing ones. So for example, the state 2 will be the row 4 in this case, right? So 1, 2, 3 will be the non-absorbing states. So that's the transition matrix, that's the S matrix, that's the Q matrix, and the identity matrix that is needed for the fundamental matrix will be 1, 0, 0, 1, 0, 1, 0, 0, 0, 1. Let's do the inverse of I minus Q with Maple. Here, for example, if I add the entries on the first row, that's going to be 1.4 approximately. That's going to be the number of times you would be expected to play until absorption, if you have $1 to begin with. And then if you have $3 to begin with, you have 1.6. Okay, let's do the T times S. That'll give me the probability of eventually being absorbed in a specific state. So notice that the values here, and notice that they make sense, right? So if I start with $1, so let's write actually using words here. So if I start with $1, then the probability of going broke is 0.84. That is the highest probability of going broke, right? Because you have basically one chance to move on with the winnings or to lose. And then if the more dollars you have in the beginning, the more chances you have to stay in the game. So if you have $3, look at this entry over here, then the probability of going broke, because the first column is going broke, it's 0.36. So the lowest probability of going broke is 0.36, and that happens if you have $3. What is the highest probability of winning $4? Well, obviously, again, if you have the same amount of money. So if you have $4, it's 0.64 the probability to win $4. If we start with $3, I said that already. If I start with $2, the probability of winning $4, so stopping the game with $4 is 0.4. That's going to be precisely this entry. Again, remember the meaning of each row. That's the key thing, right? That's why we label these rows on paper, right? So 1, 2, 3, the dollars you start with, and here 0 and 4. So I hope that's clear, and that's it for the topic on Markov chains. I'll see you next time.